Students, in this video, we will be discussing about nodal analysis. Nodal analysis is widely used to find voltage across any element in the circuit or current through any element in the circuit. So to demonstrate nodal analysis, I am using the same circuit that I have used it for mesh analysis. The first step in the nodal analysis is identify the principal nodes. The principal nodes. So this particular node where VA and R1 are getting connected, this is a simple node because only two elements are getting connected. If more than two elements are getting connected, then you call that as a principal node. So this node is a principal node where R1, R2 and R3 are getting connected. This is also a principal node where R3, R4 and R5 are getting connected. This node where R5 and VB are connecting, this node is called as a simple node. So you need not consider that now. And this is a node where VA, R2, R4 and VB all are getting connected. And this node is a ground node. The second step is to assign node voltages to all nodes except the ground node. So ground node is at a zero voltage or zero potential. So here there are two nodes, node 1 and node 2. Other than ground node, there are two nodes. Now I will assign node voltages. Node voltage, let me give the node voltage name as V1 for the node 1, and this will be given V2, which is a node voltage for the node 2. The third step is to apply Kirchhoff's current law, KCL, to these nodes except the ground node. So now I am going to apply Kirchhoff's current law to the node. In node 1 there are three segments, R1, R2 and R3. The current through R1, current through R2 and current through R3, sum of all these currents should be equal to 0 at this particular node. We know that to find a current through a particular element, for example, if this is a resistor R, and at this point if we are going to have a potential V1, and at this point if we are going to have potential V2, then the current through R is given by if V1 is greater than V1 minus V2 divided by R. So current I is equal to V1 minus V2 by R, assuming that V1 is greater and the current direction will be like this. So this is how we find a current through a particular resistance. Likewise, current through R1. Okay, now I am going to write node 1 equation. I am going to apply KCL to node 1. So it is current through R1 is V1. I am going to take a V1 to be greater. So V1 minus VA divided by R1. So while writing node 1 equation, V1 should be taken as greater potential. So V1 minus VA divided by R1 is the current through R1, and current through R2 is nothing but V1 minus 0. The other end of R2 is at the 0 potential. So V1 V1 minus 0 divided by R2. And current through R3 is given by V1 minus V2 divided by R3. So sum of all currents is equal to 0. Likewise, for node 2, if we apply the Kirchhoff's current law, let V2 be greater. So V2, while writing node 2 equation, you have to write it as V2 minus the other end is VB. So V2 minus VB divided by R5. This is the current through R5, and V2 minus V1 divided by R3. This is current through R3, and V2 minus 0 divided by R4. This is current through R4. Sum of all currents is equal to 0. I have got two equations now. Two node equations. rewriting these two equations 1 and 2 such that here it comes like v1 coefficient, v2 coefficient is equal to constant, v1's coefficient, v2's coefficient and is equal to constant. So I have written it in a very simpler format now so that it is easy for me to convert it into a matrix. Students can either solve these two linear equations straightly and find node voltages v1 v2, or they can convert these two equations into a matrix format and then use Cramer's rule to solve for v1 and v2. So this is the matrix form of representation of these two equations. So after writing the matrix equation, you can get a v1 by the formula del 1 by del and v2 by the formula del 2 by del, where del is nothing but determinant of this matrix and del 1 is nothing but to this matrix replace the first column with the right side vector. So first you have to remove the first column and replace that with the right side vector, and for that particular matrix if you find the determinant, that is del 1. And del 2 is nothing but for the same matrix, replace the second column with the right side vector and find the determinant, and that will be the del 2. So you can find a node voltages v1 and v2 by using del 1 by del and del 2 by del formula. This is how nodal analysis is done. So now let me redraw this circuit for more clarity. Let me replace this VA in series with R1, voltage source in series with resistor R1 to a current source. Similarly, VB in series with R5 to a current source. So this is the equivalent circuit. Okay, this is the equivalent circuit, but I have converted the voltage source into a current source. Here also I have converted voltage source into current source, and obviously the resistance comes in parallel now. So once the circuit is drawn only with respect to current sources in place, then writing this matrix is very straight. It's very straight, and I'll tell you how to get it. See, two nodes are there in this circuit, so 2 cross 2 matrix the students have to form. The first element, 1 element, is formed by summing the reciprocal of the elements connected to node 1. So summing the reciprocal of the resistances connected to node 1. So how many resistance are connected? R1, R2, R3. So reciprocals are 1 by R1, 1 by R2, 1 by R3, sum it. 1, 2, first row, second column is got by what is the element connected between node 1 and 2. So it is R3. Make a reciprocal along with a negative sign. So 2, 1. Second row, first column element is given by, again, what is common between second node and first node? Make a reciprocal with a negative sign. And 2, 2 is nothing but sum of reciprocal of resistances connected to the node 2. So here R3, R4, R5 all are connected to this node 2. Make a reciprocal of every element and sum it. So this is how you build a R matrix, 1 by R matrix, which is multiplied by another vector of node voltages, that is node voltage V1 and V2, is equal to, the right hand side is given by the currents. VA by R1 is nothing but, see here, VA by R1 is the incoming current to this particular node. Since it is incoming, I have given a positive sign here. So incoming current is VA by, here it is VA by R1 to this particular node. So it is VA by R1. Similarly, for node 2, the incoming current is VB by R5. So we have given here VB by R5. So this matrix is of the form, one matrix formed with all 1 by reciprocal of resistances, another matrix formed with voltages, and right hand side is formed with currents. I is equal to V by R. So students, this is how nodal analysis is done to obtain the node voltages V1 and V2. So in the next videos coming, we will solve more problems so that we will get a hold on to this nodal analysis better. Thank you.